All right, algebra. Today what we're going to do is linear functions. And build upon what we did last week when we were talking about a relation, and then a function is a special relation. And so we are going to talk about linear today, although there are others. For example, you can have a parabola, which is not a linear function. Let's see. And like its name, we are on page 24. Obviously, there's going to be a line, okay, because it's linear. All right, so if you remember last year, we talked about multi-representations. And so we're going to take that and kind of go fast forward with it in algebra. So when you have a linear function, oh, I'm missing my pens. Hold on, guys, I'm going to go grab all my pens. So like we talked about, the linear functions, remember when you have an independent variable, right? You don't have to draw this, but just get the idea, right? Same idea. When your x goes in, you have a rule here. And it spits out the y, okay? So, for example, let's say that y is equal to 2x minus 1, okay? This is obviously our equation. Now, we can create a table from this. And a table, remember, you can have a horizontal table or a vertical table. The vertical is the easiest because if it is a horizontal, the x many times is on top, and it will get easily confused when we get into slope, and I'll explain that later. So I prefer always use a vertical table. Now, who knows what the x is? We don't know. But the rule tells us that there's a certain relationship between the x and the y when I put a specific value in it. So, for example, if x is equal to 1, okay, when x is 1, okay, all I did, and this is function notation, and we're going to go over that in a little while, but I want you to realize your rule would be 2, so I'm going to substitute a 1 in for x, and that equals 1. 2 times 1 is 2, minus 1 is 1. So y is 1. What if x is 2? Okay, so the function of x, when it's 2 times 2, that's right, minus 1 is going to give you 3. And we could go on and on and on. I could pick the number 9 if I wanted to. So the function of 9 is equal to 2 times 9 minus 1. 2 times 9 is 18, minus 1 is 17. Okay? We're not going to get into slope or writing the rule today. I just want to review, how do we come up with a table? How do we come up with ordered pairs? Okay, the ordered pairs, all we're doing is 1, and we're putting it into, and these are the only ones that I calculated, right? Because there are some missing. For example, when x is 3, 4, 5, 6, 7, and 8. Okay, so the set of ordered pairs doesn't always represent the exact pattern. It just says that it's on the line. Okay, and the last one is when we have a graph. Okay, and you only need 2 ordered pairs to draw a line. Okay, I have my x and I have my y. It's my origin. So I'm going to calculate 1, 1. And then I have try to get the same. This is just for, so now all I have to do, and yes, I do not have a ruler on me, so I'm just going to use the side of a pen. Okay. And it's going to cross through. Okay. It did not go through the origin. This was just a rough sketch, everybody. And it would be very easy. I don't want to give it away right now, but this does not go through the origin. Okay. It actually goes through a -1. Okay. So multi-representation, any one of these represents this linear function. This is a linear function. This is a linear function. And we tend to gravitate towards the graph because we obviously see a line. But when we're working with ordered pairs and tables, we have to find a trend, and we'll get into that in the next few lessons, talking about finding slope and constant rate of change. But for today, I just want you to realize when your independent variable, okay, it depends on your independent variable for the outcome of y, okay? Let me get your classwork. Miss Kowalski was not prepared. Okay. All right, everybody. So what you're going to do today is right here. So if you notice, they gave you a rule, but they didn't, can you pick any x? Sure, absolutely. And I love to always use 0 because it's easy. 2 times 0 is 0, right? So substitute it. So it's a -7. If I put in a 1, 2 times 1 minus 7, -5. Okay, can I do a 2? So we're seeing a pattern, aren't we? So 4 minus 7 is a -3. And I'm going to pick these smaller values. So when x is 1, 1, 2, 3, 4, 5. When x is 2, y is 1, 2, 3. And so I can draw. Please use a ruler. I know I'm not because I don't want to walk across the room again. There you go, and that's all you're doing. So what I do want you to do, I'm not going to make you write the ordered pairs. That's fine. So you have your equation, you have your table, and your ordered pairs are already given for you. This just helps you to take the time to write out the equation. Don't do it in your head, Adrian. Okay. On the back, you notice that there's a table. This equation right here, the table for it when it printed was on the back. This is not a lot of work. I think you'll be fine. I want you to ponder this. Have discussion. I'm not going to grade this, but what I do want you to do is, what does it look like? And we'll talk about it when you come to a lesson tomorrow, because it's in different forms. I want you to use your critical thinking skills and think about, is it a linear equation and why? So it's really kind of a warm-up for tomorrow. Now, for the calculator portion, this is how you use the calculator. And yes, Ms. Kolsky had to run across the room because I didn't have a calculator ready. I was not prepared. Okay, so you're going to go back to the home screen. Okay, you're going to go to graph. Now, if you notice, it's already got a graph. You should have numbers like a 10, and you can always zoom in your graph or zoom out, and it's part of the functions when you go here, graph entry, the window zoom. Play around with it. All right, so I'm going to go back. Now, I already pushed tab. I can delete. Whoops, sorry. All right, so I erased that. To get the function where you want to put it, you push tab. And if you notice, it's saying that the function of x, and that means y. The 1 actually means this is your first equation line. So all you're going to do is you're going to say y equals, so that's what that stands for, is the y. You don't have to put that in anymore. And you're going to put 4/3. So 4, and then I'm going to put a 3 for the denominator. And guess what? And it's going to graph it for me. So I want you to copy that. So not only can you create a graph mathematically, but you can also utilize your calculator as a resource. Okay? And you only have 3 of those, and then I want you to look at this one because you're going to draw 4 of these on the same, and it'll be a discussion for when we gather tomorrow. All right? Great job, algebra. See you today.